So let's assume what is happening with it. Anyway, I'll just correct it. No worry. Why this is happening, I don't know. Maybe version problem. So I'll explain this one. If I convert this into PDF, then what will happen? Yeah. Again, okay, no worry. So here, let me explain the problem statement. Might be because of the Grammarly problem. Let's assume that you are an analyst in a company and they have 10 employees whose salaries, this is salaries, are given below. The company's HR manager wants to gather some data for presentation. So he asked you to find some specific information for him. Check the question beneath the data table and arrive at the solution for HR using Python. Yeah, for the HR using Python. So this solution will be trying to do, yeah, using Python, and meanwhile we'll be working on the, we'll be doing some statistical calculation too. So I hope this problem statement is clear to everyone. Yeah. So, for this data, basically the employee number and the monthly salary have been given. So we'll be doing the descriptive statistics for the problem given. And we'll try to conclude. So let me open the Jupyter file. So I'm just writing here. So first of all, we are working on the simple one, and then I'll be taking the entirely industry relevant data set. Yeah. All right. So first of all, just to read the data, we will be requiring the pandas, NumPy, all right. Let me use the data set, but you can see here that they have not provided any data set. Yeah, they have not provided any data set. This is the data they have given, and accordingly we'll have to work upon. So it means we'll have to create our data frame. We'll have to create the data frame by ourselves. So Arya, Dr. Arthi, Mr. Ricard, can you tell me how I can create data frame with this data? How?
Using NP array.
With using?
NP dot array.
Array. Okay.
Yeah.
Any other option? Because array will not have the column name. Isn't?
Yes.
So what is the another option?
Creating a dictionary.
Exactly. So we'll be creating a dictionary here, and then we'll convert that dictionary into data frame. Let me show you. So so Dr. Arti, please tell me what is the number here so that I can create them. And where's the Jupyter?
I have a question here.
Yeah.
So, are we using a Jupyter notebook or a Google Colabs?
See, you can use Jupyter Notebook or Google Colab. I'll be using Jupyter Notebook, but if you are using Google Colab, it's fine.
Yeah, okay. So I think for me the Colab is matlab, I've already
Full.
moved to Colab from
No worry, no
from
worry. Because you will find that the interface of the Jupyter and the Google Colab both are same or similar.
okay, fine.
Even when I'll be working on deep learning, in that case, I'll also move to Google Colab.
Okay. Yeah.
Yeah. So let me open the Jupyter. Hmm. This was there, no? Okay. Now, let me create the dictionary. So what I'll do, I'll first create the dictionary. So let's say I'm taking the variable name as my dict, and here I'll be creating the dictionary. Okay. So in this dictionary, what was the first data? EMP number, isn't? So I'll take here EMP underscore number, colon, and then
The value
huh, what was that?
one.
Monthly salary, yeah?
Uh, the next one is monthly salary.
Monthly salary. Fine. Okay. So in this EMP number, I'll be taking a list. In the monthly salary also, I'll be taking the list. So what is the value they have given? 1324.
1, 3, 2, 4, 5, 6, 7, 8, 9, 10.
4.
5, 6, 7, 8, 9, 10.
And in the monthly salary, what is the value?
90,
90,
18, 80, 18, 17, 3 times 16, consecutive 16, 15 and 14.
fine. So this is the dictionary I have created. Okay. Now I take a variable name as yeah. So I'll simply take df equals to pd dot data frame. And here I'll be writing my underscore data. Yeah. Now if I show you, see, we have converted this into data frame. Please do it everyone first so that I can move further. I'm waiting for your call. Once you're done, do let me know.
Done, sir.
Done. Okay. Dr. Arti?
Yeah, done.
Okay. Now, let's do some basic and then we'll try to map it with the question asked. So first of all, let me find out the measure of central tendency. So measure of central tendency means where the value is centrally located. Yeah. And if you have to find out the measure of central tendency, we'll be finding out mean, median, and mode. Yeah. Where this mean and median, this is for the continuous data. This is for the continuous data. Continuous data means, I mean to say, the data that will be containing decimal also. The data that will have decimal also, like, age, even, or that may or may not have decimal. But the mode is used for categorical or discrete data. Yeah. So let's do that. So salary is a continuous data because it can be the complete number or it can be in the decimal. So now what we will do, see, let me find out DF. And if I want to access this salary, so how can I access DF? In square bracket, we'll be writing salary. Sorry, in our case, it is written as what? Monthly salary. Monthly salary dot mean. So the monthly salary is the mean, that is the simple average, arithmetic mean simple average is coming as 30. So how exactly we have calculated this? So we were simply finding out the average of this. We simply found the average of this and that have been the mean of our data. Yeah. So let me take a screenshot of this. Okay. Now, what is the average of this? So how you'll be finding out the average? Simple, 90 plus 18 plus 80 plus 18 plus 17 plus 16 plus 16 plus 16 plus 15 plus 14 upon 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So what is the answer you are getting? Please calculate this.
30.
30, isn't? Because we have already seen the answer, isn't? Okay. Now, how to find out the median? As I've said to you that for the continuous data, we can find out the mean and median both. Yeah. So we have calculated mean. Now let's see how we will calculate the median. So, this median is the calculating median. The formula is different if we have even number of distribution, and the formula is different if we have the odd number of distribution. So right now, you know that we have the even number of distribution because the total data is how much? How many data we have? 10, na? Yeah. So since the total data is 10, that means we have the even number of distribution. So whenever we have the even number of distribution, so the formula is at that time value at n by 2 plus value at n by 2 plus 1 upon 2. Where n is what? N is the total number of data. Total number of data. Okay. And dear friends, before calculating this in median, we need to arrange the data in ascending order first. We need to arrange the data in ascending order first. So we'll be first arranging them in the ascending order, then only we will be finding out the median. Okay. So as I was saying that this is the formula when we have the even number of distribution. Like we have 10, no? So even number of distribution. When we will have the odd number of distribution, then the formula will become value at n plus 1 upon 2. So this is the formula. So this is the formula when we have the odd number of distribution. Okay, everyone? Now, so first of all, as I've said to you that we need to convert this into ascending order. So this is the data, na? This is data. Let's convert them into ascending order. So what is the minimum value? 14. After 14, 15. Then 1, 2, 3. 3 times we have 16. Then how many times? 17. Only one time we have the 17. Then 2 times we have 18. And then 80 and 90. Yes? This is the ascending order of our data now. Yes or no, everyone? Mr. Ricord?
Yes.
Yeah? Dr.
Yes, yes.
Okay. So now we will apply the formula. We'll apply the formula over here. So what is the value of n? N equals to 10 here, no? We have total, how many value? 10. So if I put this in into the formula, so value at 10 by 2 plus value at 10 by 2 plus 1 upon 2. So it means we want to have value at 5. So 1, 2, 3, 4, 5. Isn't? So the value at Value at 5. Value at 5 is what? 1, 2, 3, 4, 5, 16 plus 10 by 2, 5 plus 1, 6. Value at 6. So 1, 2, 3, 4, 5, 6, 17 upon 2. It means how much? 16 plus 17 upon 2. So what will be the answer?
16.5.
16.5. So this is the 16.5 is what? It is the median. It is the median. Fine, everyone? Yeah. So the question arises, if the mean and median both are the central point of the data, if the mean and median both are the central value of the data, So which one is to be preferred? Which one I should prefer to consider the central value of the monthly salary? To consider central value of the monthly salary. Tell me, everyone. So this is interview related question. In that case, everyone, whenever your data will have outlier, whenever your data will have outlier, use median as your central point. If you have outlier in your data, then use median as the central point. Don't mean. Why? Because mean is affected by outlier. There will always be impact of outlier on your mean. But median is not affected by outlier. So normally mean is considered as the central point, but if your data is having outlier, in that case, median will be considered as the central point. Clear, everyone? Clear?
Clear. Yes.
Okay. So this is the where is that? Where's the Jupyter? In which browser it is opening? It is opening in the Copilot. It is not showing here. Anyway, I'll look into this. Yeah. So you can see here. So simple. If I take here, I'll just simple call it. Yeah. And we'll see here. Median. See, 16.5. And I tell you that the mode is always used for categorical data. The mode is always used for categorical data, since in our case, there is no categorical data. So we will not be able to find out the mode. But let's say, everyone, that let's say, for example, male, male, female, female, male, 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 for example. So what is the frequency count of male here, everyone? 1, 2, 3, 4, 5, 6, 7. Male is coming for 7 times. 1, 2, 3. Female is coming for 3 times. So you can see here that the frequency count of male is 7. That's why if you will find out the mode of the gender column, let's say, so in that case, the mode will be 7. The mode will be 7 because there were two unique category, and out of that, male frequency count is higher than the female. Yeah, everyone? So this is how the mode is calculated. Okay, the mode is calculated, and let me do one thing. Yeah, okay. For example, let me take by simply let's see this data. So here, for example, if I talk about this one now, this data. So you can see here this attrition and the business travel. They are what? They're the categorical data, no? They're the categorical data. So let me find out the mode of the business travel. Let me find out the mode of the business travel. So I'll simply take here business travel dot mode. BUSINEWS. See what is the mode? Even if I take here 0, what is the mode of the business travel? Travel rarely, no? Yeah. So how it has calculated? It just first of all calculate the frequency count of each category in the business travel, and then whichever category will have the highest frequency count, it will declare it as the mode. Let me show you. So if I simple go with it, we'll paste here, and then I'll simple call the value underscore counts function. Yeah. So you can see that out of this 2940, the travel rarely is coming for 2086 time, travel frequently for 554, and non-travel is coming for 300 times only. So you can see out of this three, this 2086 the highest one. This is why the travel rarely is coming as the mode. I hope you understood now, everyone.
Yes.
Yeah. Okay. Then let's talk about the variance. Let's talk about the variance. So, what is the meaning of variance? Variance means, or the measure of a spread. So let's say this is the central value, this is my mean, and this is my data point, the records. So how far this data, one second, no? So how far these data is from my central point? This is I calculate, I just find out through variance and standard deviation. And what is the range and interquartile range? So I'll just tell you that how we calculate this. Yeah. Then we will see that how we can do it in the Python. Okay. Yeah. Fine. See, so the first thing, as I've said to you, that in the measure of spread, we are coming up with the range. So how the range is defined? Whatever column whose range you want to find out, it is find out through the maximum minus minimum. So in this data, what is the maximum value, everyone? In this data, what is the maximum value? 90.
90,
And yeah,
And what is the minimum value?
14,
So what is the range here?
76.
76. Let's talk about the interquartile range. Okay. So let's say this is the box plot. This is the box plot. Now, this is my minimum or the lower limit. This is the upper limit. Lower limit will be the best one. Okay. This is Q2. This is Q2, which is actually the median of the data. So in this case, what is the Q2, everyone? In this case, what is the Q2?
Q2.
16.5. Remember, median. Yeah, as I've said to you that Q2 is what? It's a median of this data. So in our case, what was the median of this data? 16.5, remember, everyone?
Yes.
Yeah. Now,
Mhm.
make me correct if I'm wrong. What is this? So basically, this is Q1 and this is Q3. And how the interquartile range is find out? So the interquartile range is find out through Q3 minus Q1. Q3 minus Q1. It means if I somehow able to calculate the Q3 and the Q1, I can easily find out IQR, no? Interquartile range. I'll talk about that, why this IQR is needed. So if you just look at this box plot, can I say that this Q1 is nothing? It is actually the median of the first half. This Q1 is nothing. It's a median of the first half. Can I say it, everyone? See? Yeah. In the same way, this Q3 is nothing. It's a median of the upper half. Yeah. It means if somehow I'm able to find out the median of the lower half, it means I find out the value of Q1. And if I able to find out the median of the upper half, then I have find out the value of Q3. Yes or no, everyone?
Mhm.
Yeah. So
Yes.
even if I consider the same example, so 1, 2, 3, 4, 5. This is the half now. This is the lower half.
Mhm.
This is the lower half now. Because I'm talking about the median, so obviously my data should be arranged in ascending order. And this is my upper half. Yes or no?
Yes.
Arya, Dr. Aarti, Mr. Ricard.
Yes.
Yeah. So what is the median of this one? What is the median of this one? So this time, you know that if I
Yeah.
talk about this data, this is number of data is odd or even?
Odd.
Odd. So for
Yes.
odd, what is the formula? Formula was value at n plus
And
1 upon,
2.
yeah. It means n is what? 1, 2, 3, 4, 5. So 5 plus 1, 2, 5 plus 1, 6 upon 2. Value at 3. What is the value at 3, everyone?
16.
16. So this is
Mhm.
this Q1. This Q1 is what now?
16.
16. Let's talk about the upper half. In this upper half, what is the median? So again, the values are 5. So value at 3, 1, 2, 3. This Q3 is
18.
18 now?
Mhm.
Yes or no? Yep. So
Yes.
if the Q3 is 18 and Q1 is 16, so what is the IQR? What is the IQR?
18 minus 16.
2.
Mm.
Yeah. 18 minus 16 equals to 2. Let me check. This is giving us the maximum. So maximum minus minimum equals to range. Remember? Let me find out the quantile. So dot quantile. And when I'm writing 0.25, it means 25%, 0.5 for Q2 and 0.75 for Q3. So if I'm running it, see, this is same now. 25, 16, 16.5 and 18. Remember, this we have calculated. So let
Yes.
me find out the IQR. So the IQR will be calculated as .25 minus what happened? Minus 0.75. What happened? I did mistake. 0.75 minus 0.25. Yeah. So this is the interquartile range. So dear friends, I tell you that this IQR is really very crucial if you want to find out the outlier. In case of outlier, this IQR is really very crucial. Why? Because If you remember, in box plot, we had discussed how to identify the outlier. Who will tell me? I told that this is my upper limit, this is my lower limit. If you see any value that is upper than upper limit, it is an outlier. If you see any value that is lower than lower limit, this is an outlier. Yeah, everyone? Yeah. So if I somewhere get the value of the upper limit, if I somewhere can calculate the value at the lower limit, can I say that I can easily find out the outliers? So how we can find out the upper limit and the lower limit? This is the question. So the upper limit is calculated as Q3 plus 1.5 into interquartile range, while the lower limit is calculated as Q1 minus 1.5 into IQR. That means what, everyone? That means if let's calculate the upper limit. So what is the value of Q3 in our case? 18. Yeah. And what is the value of IQR? 2. So 1.5 into 2 is what? 3. So this 21 will be my upper limit. And what will be the lower limit? So you know that the Q1 value was 16 minus 1.5 into IQR is what? 3. So the lower limit will become 13, sorry. It means in this data, any value, if that is less than 13, this is an outlier. Any value that is greater than 21, this is an outlier. So please tell me, do we have any outlier in this data?
Yes.
Huh? Do we have any outlier?
Can you find
Yes,
out? Yes.
Yeah.
we do have two values, one with 80, another one with 90, right?
So these are the outlier,
And the upper limit.
upper limit. We don't have any value which is
Less than
lower
30.
than lower limit. Yeah. Okay. See, so this is how we can find out the outlier. Now, let me find out the variance and standard deviation. And actually the purpose is to find out the standard deviation. And that standard deviation can be find out by variance. So that's why we'll be calculating the variance first, and then we'll be calculating the standard deviation. And you know, the standard deviation is nothing. It is the square root of what? Variance. Okay. So you can see here, guys, that the mean of our data is what? 30. Mean of our data is 30. Yeah. Okay. Fine. All right. So what is the mean of the data? That is 30. You know how the variance is calculated? So the variance is calculated as summation of I equals to 1 till n xi minus x bar. What is this x bar? Upon n. This x bar is your mean. This x bar is your mean. And here it will be whole square. So let's first see xi is what? Individual values. So first of all, let's subtract each value with by 30. Na? So 90 minus 30 whole square, 18 minus 30 whole square, 80 minus 30 whole square, 18 minus 30 whole square, 17 minus 30 whole square, 16 minus 30 whole square, 16 minus 30 whole square, 16 minus 30 whole square, 15 minus 30 whole square, 14 minus 30 whole square. So 90 minus 30 is what? 60? 90 minus 30 is what? 60? 60 square is what? 3600? 18 minus 30 is what? 12? Minus 12 or 12, whatever. Yeah? 12 square is what?
144.
144. 18 minus 30 is 50. 50 square is 2500. 18 minus 30 is again going to be 144. 17 minus 30 is going to be what? 13. And 13 square is what? 169.
Okay.
Yeah. 16 minus 30 is what? 14. 14 square is going to be 256. 16 minus 30 is what? Again 14 means 256. 256. 15 minus
14
30.
square is 196, right?
Yeah, I always do mistake. Thank you. Thank you, Dr. Aarti. This is 196, isn't it? Because even I was shocked that 14 square is 256 and 15 square is 225. So this is again going to be what? Now this will be 256, isn't it? Yeah. Everyone, please add this. Please do addition of this because this is going to be summate, na? So what is the summation of this? So please do it. I'm waiting for your call.
7,626.
7,626. This is the sum of this, isn't?
Yes.
Okay. Now, how many values we have? 10 now? Please divide it by 10. So what is the answer?
762.6.
So this is what?
Variance.
This is the variance. Now, what is the standard deviation? So the standard deviation will be under root 762.6. Please tell me, everyone.
Uh, 27.615.
20, huh? 27.65.
615.
Okay. What does it mean? What does it mean? Any interpretation? Yeah. It means, it means whatever salary will be given, what will be salary is there, it is going to be varied Yeah. So most salaries in this data set tends to vary by approximately 27.615, either above or below. Either above or below. Yeah. From where? From your central point. And what is the central point, everyone? 30?
16.5. Okay, 13.
Yeah. So most of the data is going to be varied by either 27 up or the 27 down. Most of the data. It means the most usual range for this data is going to be by 57. I'm taking it as 27 around, and it is going to be 3. But you know why this is not matching with our data? Why this is not matching with our data? Because see, maximum data are falling near 18 and 16, 17. Then why this is not happening? Because you know, in our data, there's an outlier. In our data, there's an outlier. Because of this outlier, the actual mean we are not getting. The actual mean we are not getting. Our mean should be, our mean should be around 16, but we are getting 30. Why I'm telling you? Because you know that the median is 16.5. The median is 16.5. So we will discuss them later on. Right now, let's be stubborn on the values. And you can see here that according to this is the standard deviation, that is 27.615. How we have calculated, you have seen. And what is the interpretation? So the interpretation is that most of the data will be varying by approximately 27 up or 27 down. Makes sense? Dr. Aarti, Mr. Ricard, Arya,
Yes.
yeah? Mandar, any question? So in this way, see, right now we have done what? We have simply calculated it and we have seen here. Now, in the next session, we will just map it with the problem statement that we have received. We'll simply map it with the problem statement that we got. Yeah, this one. Okay, whatever question were asked, we'll try to answer this using this notebook. Okay.
Thanks for watching the video. Our knowledge partners, certification alliances and curriculum creators are. Join our popular courses and get an immersive learning experience as we proudly serve as a global trailblazing training solutions provider, dealing with driving a revolution in upskilling by offering comprehensive and specialized training programs. Following are our services: instructor-led virtual training, on-site training, corporate training, exclusive and individual training, self-paced training, classroom training, customized training, campus training. To know more about our courses, visit our website. Don't forget to like, share and subscribe the video.